All right, so the way you're going to find gravity, how are you?
I'm good, how are you?
Good. Okay, so you dropped your mass through the paper tape machine, right? The machine made 40 dots per second. So the record of the falling mass's motion will look like this. You're going to have, your first dot, and then it's going to be like that, and that. And then what's going to happen to the dots? They're going to be farther and farther apart because the mass is going faster and faster and faster. So what you want to do is you want to label the time. So this first dot here is 0/40ths of a second. This next dot, so if the machine makes 40 dots per second, what's the time from one dot to the next dot? 1/40th. So that next dot's going to be 1/40th of a second. Then the next dot's going to be 2/40ths of a second. Then 3/40ths of a second, and then so on, 4/40ths. You're only going to have about 15 or so dots. When you did the toy car lab, anybody remember how many dots you had?
A lot.
It was like between 40 and 60 dots. For this lab, it's going to be a lot fewer dots because why? It moves a lot faster. The mass is going to go boom, like right through the machine, real quickly. So go all the way out to you'll have about 15 dots. Now, on your data table here, the time column, you're going to go like this. So you're going to go 0/40ths, 1/40th, 2/40ths, and then go all the way down to 15/40ths. So keep going until you get to 15/40ths. This delta x column. Okay, so ultimately what you want to figure out is the velocity at each of these points. So for example, how could we find the velocity at 2/40ths of a second? How could we get a good estimation of the velocity there? Well, what's the definition of velocity? Displacement over time. Okay, the displacement that you're going to use for finding the velocity at 2/40ths is from the previous dot. So notice on the lab it says that delta x is the displacement between adjacent dots. So the delta x that you're going to record for 2/40ths is this. This is the delta x that you're going to measure for 2/40ths of a second. What would be your delta x for 4/40ths? When you're over here at 4/40ths, what's the delta x going to be? It's going to be from 3/40ths. So you're always measuring how far the mass went from the previous dot, which is different than the car lab. If you think back to the car lab, you were recording positions, so you were always measuring from where? From the zero. You were always measuring from the first dot. For this lab, you're measuring from the previous dot. Does that make sense? Because what you're trying to do is you're trying to figure out a good idea of the velocity at each of these points. So you want to figure out how far did it go in the previous 1/40th of a second. Does that make sense? And in reality, so if you do what I just said, in reality, you're actually finding the velocity in the middle. You'd be finding the velocity like there, right in the middle of those two dots. Okay? So, this delta t column, the entire delta t column is going to be 1/40th, all the way down. 1/40th, 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 because why? Delta t is the time from one dot to the next dot. What's the delta x for 0/40ths? So 0/40ths is right here. How far did it go from the previous dot? 0, because there is no previous dot. So that's 0 meters. All right, so what's the velocity going to be at 0/40ths? 0. You can just fill that in right now. At 0/40ths, the velocity is 0. Okay, so let's find the velocity at 1/40th. How would you find the velocity right here at 1/40th? At 1/40th, how do you find the velocity? You're going to measure that displacement, right? You want it to be in meters. So how do you get that in meters? First measure it in centimeters, then divide by 100. Okay, so let's say that that's, I don't know, 0.0, how far would it go? 0.035, so go out like that, something like that. So I just made that up, guys. You're going to have something different. So how would you get the velocity from that data? This velocity that goes right there is going to be what? Velocity is delta x over delta t. So your delta x, let's just say it's 0.035 meters. The delta t is what? 1/40th of a second. So the velocity at 1/40th comes out as 1.4 meter per second. Okay, then you go to 2/40ths. How do you find the velocity at 2/40ths? Well, you first have to measure your delta x, which is this in here. So 2/40ths is right there, right? So you measure this delta x and then divide by the time, which is 1/40th. Does that make sense? Okay, go to the back page of the lab. What it tells you to do, and now we're getting to the good part, what it tells you to do is plot velocity versus time. So you're now going to create a velocity versus time graph. Okay, so you're plotting this column and this column, time and velocity. Okay, what should this graph look like? What was accelerating the falling mass? What was causing that mass to fall? Gravity. Is gravity constant or not constant? It's constant. Near the surface of the Earth. Near the surface of the Earth. If you leave the Earth, it's not constant. It gets weaker. But when you're on the surface of the Earth, gravity is a constant. Okay? So, what should this line be? Curved or straight? Straight. Because remember, what's the slope of a velocity time graph? Acceleration. Right? Gravity's constant, so the slope of this line should be constant.
Where is this in the packet?
We're on the back side of the first page. Number 1. This is number 1 on the back side of the first page. All right, so look, you're going to go like this. So once you have it, once you have the graph created, you're going to take the slope of this line. Okay, so the rise is the change in velocity. The run is the time. So slope equals rise over run. The rise is change of velocity. The run is the time. What is that? What is this? That's the acceleration. If you measure your displacements carefully, you know, when you're on the paper tape here, if you measure these delta x's carefully, I promise you, the slope of this line should be what? 9.8. You'll get, or close to it, or very, very close to it. It's a super cool lab. Any questions? All right, so graph paper is up here if you need graph paper. But otherwise, this is what we're doing for the period. So there's 4 stations set up. Let me know if you need help.